Fusion energy, the power of the stars. It's one of the most amazing things in the universe. Fusion energy is a huge source of power. It has the potential to change how we use energy here on Earth. It's what makes stars shine. Every star, including our sun, uses fusion energy to give off light and heat. Fusion happens when tiny particles called atoms combine to form bigger atoms. This process not only creates energy, but it also makes new elements. This process releases a tremendous amount of energy. This energy could be used to power millions of homes. Scientists want to recreate this process on Earth. They are working hard to develop fusion reactors that can operate safely and efficiently. Fusion energy would be clean, safe, and almost limitless. Unlike current nuclear power, fusion energy doesn't produce long-lasting radioactive waste. Imagine a world powered by the same energy source that fuels the sun. A world no longer dependent on fossil fuels, no more fossil fuels, no more pollution, no more industrial chimneys spewing harmful smoke. That is the promise of fusion energy. A bright, clean, and sustainable future for all of us. China is making huge strides in the field of fusion energy. With their continuous development, they are getting closer to creating a clean and endless source of energy. They are investing heavily in research and development. These investments are not only coming from the government, but also from private businesses and international organizations aiming to commercialize fusion energy and potentially surpass the US in the future. China is building new, modern facilities. These facilities are equipped with the most advanced technology to ensure efficiency and safety during research. They are attracting top scientists and engineers from all over the world. This international collaboration helps China access the latest knowledge and technology. Energy Singularity, a small startup in Shanghai, is finding ways to harness fusion energy. While US companies and industry experts are concerned that the country is losing its leading position in the race to master this nearly limitless form of clean energy, a series of new companies like Energy Singularity have emerged across China, according to CNN. Fusion reactions, the process that powers the sun and other stars, are very difficult to replicate on Earth. Many companies have achieved fusion reactions, but maintaining it long enough for practical use remains a challenge. The advantage of fusion energy is its extraordinary efficiency. A controlled fusion reaction releases 4 million times more energy than burning coal, oil, or gas, and 4 times more than fission reactions, the type of nuclear energy commonly used today. While research has not progressed fast enough to address climate change, it holds promise as a solution to future warming. The Chinese government is pouring money into fusion energy development, estimated at $1 billion to $1.5 billion annually, according to Jean-Paul Alain, head of the Office of Fusion Energy Sciences at the US Department of Energy. In comparison, the administration of US President Joe Biden spends about $800 million annually. Private businesses in both countries are optimistic and say they can put fusion power on the grid by the mid-2030s, despite the enormous technical challenges. The US was among the first countries in the world to conduct fusion research, starting in the early 1950s. China explored fusion energy at the end of that decade. Recently, they have accelerated their efforts. Since 2015, the number of fusion energy-related patents in China has skyrocketed and is now higher than any other country, according to industry data released by Nikkei. Energy Singularity, the Shanghai-based startup, is just one example of China's rapid development speed. The company built its Tokamak within 3 years of its founding, faster than any similar reactor ever built. A Tokamak is a highly complex cylindrical or donut-shaped machine that heats hydrogen to extreme temperatures, forming plasma for fusion reactions to occur. For a young company working in one of the most challenging fields of physics in the world, Energy Singularity has reason to be confident. They received over $112 million in private investment, and their current tokamak is the only one using advanced magnets in plasma experiments. Called high-temperature superconducting magnets, they are more powerful than the copper magnets used in older tokamaks. According to a scientist researching similar technology at MIT, this type of magnet allows smaller tokamaks to produce as much fusion energy as larger ones and can confine plasma better. Energy Singularity is planning to build a second-generation Tokamak to demonstrate that their method is commercially viable by 2027 and hopes that a third-generation device could power the grid by 2035. China is committed to becoming a global leader in fusion energy. With their relentless efforts, they are laying the foundation for a sustainable future free from fossil fuel dependence. The United States has a long history of fusion research. They have made significant contributions to this field. American scientists have been at the forefront of fusion science for decades. However, competition is increasing. The United States needs to maintain its investment in fusion research to stay ahead. However, tokamaks in the US are becoming outdated, according to Andrew Holland, CEO of the Fusion Industry Association in Washington, D.C. As a result, the US relies on machines from allies in Japan, Europe, and the UK to advance research. Holland mentions a new $570 million fusion research park under construction in eastern China called CRAFT, which is expected to be completed next year. We don't have anything like that. The Princeton Plasma Physics Laboratory has been upgrading its tokamak for 10 years. The other tokamak operating in the US, DIID, is 30 years old. There are no modern fusion facilities at US national laboratories, he said. Fusion reactions are very complex processes that involve fusing two nuclei that normally repel each other under normal conditions. One way to achieve the reaction is to raise the temperature in a tokamak to 150 million degrees Celsius, 10 times the temperature of the sun's core. When fused, the nuclei release enormous energy in the form of heat, which can be used to turn turbines and generate electricity. Maintaining fusion reactions for extended periods is even more challenging. While China is leading the way with tokamaks, the US is pioneering the use of another technology, lasers. In late 2022, scientists at Lawrence Livermore National Laboratory in California fired nearly 200 laser beams at a cylindrical container holding a peppercorn-sized fuel pellet. This was the world's first successful experiment to achieve fusion energy gain, meaning the energy produced from the process was greater than the amount used to heat the fuel. We don't know exactly what the best design is, said Melanie Windridge, a plasma physicist and CEO of Fusion Energy Insights, an organization that tracks the fusion energy industry. There may be several viable approaches to fusion power, taking into account cost and many other factors in the long term, but the tokamak is the most studied design over time and the most advanced in terms of physics. Many private companies are building this type of reactor. With the amount of money China is investing in research, tokamak design is evolving rapidly. The East Tokamak in Hefei can hold plasma stable at 70 million degrees Celsius, 5 times hotter than the sun's core for over 17 minutes, setting a world record. Mikhail Maslov, an official at the UK Atomic Energy Agency, described this as a significant milestone towards the commercialization of fusion energy. While the Chinese government is pouring money into fusion energy, the US is attracting more private investment. Globally, the private sector has spent $7 billion on fusion energy in the past 3-4 years, about 80% of which is from US companies. But if the Chinese government continues to maintain its investment of more than $1 billion per year, the country could soon surpass the US, even in the private sector. Fusion energy has the potential to change our world. It can provide a clean and sustainable energy source for future generations. Imagine a world no longer threatened by climate change. Fusion energy can make this a reality. Fusion energy can also power our industries and transportation systems. It can bring energy security and independence to nations. The race for fusion energy is a global effort. Many countries are working together to achieve this goal. International collaboration is essential for success. By sharing knowledge and resources, we can accelerate the development of fusion energy. This is not just a competition between nations. It's a common goal towards a better future for all humankind. Fusion energy offers tremendous hope for a brighter future. It is a clean energy source that does not emit greenhouse gases and can provide endless power to the entire world. It is a challenging but achievable goal. Scientists and engineers around the world are working tirelessly to make this dream a reality. They are researching and developing advanced technologies to control and sustain fusion reactions. With continued investment and collaboration, we can unlock the power of the stars. Nations and international organizations are jointly investing billions of dollars in fusion energy research and development. This collaboration not only facilitates the sharing of knowledge and resources, but also drives rapid progress. Fusion energy has the potential to solve some of the world's biggest problems. It can reduce our reliance on fossil fuels, mitigate environmental pollution, and provide stable energy to communities worldwide. It can usher in a new era of clean and sustainable energy. Combined with other renewable energy sources such as wind and solar, fusion energy can create a diverse and flexible energy system. The journey to fusion energy is a testament to human ingenuity. Advancements in technology and science have brought us closer to this goal. Human creativity and perseverance are key to overcoming technical and scientific challenges. It is a reminder that we can achieve great things when we work together. Unity and international collaboration are key to making fusion energy a reality, benefiting all humankind and creating a more sustainable future.